Hello, and welcome to this online tech talk on an introduction to Postgres 13. My name is Shayan Sanyal. I'm a senior database specialist solutions architect here at AWS. So, for folks who may be new, we'll do a brief introduction to Postgres. We'll then discuss a couple of options of running Postgres as a managed service in AWS. Then we'll go over why you should upgrade in the first place. Next, we'll take a look at why you should consider upgrading to this specific version, which is Postgres 13, which will be followed by a close look at some of the new features in Postgres 13. Finally, we'll wrap it up with a quick demo. So what is Postgres? Postgres is an open source object relational database system emphasizing extensibility and SQL compliance. The origins of Postgres actually date back to 1986 as part of the Postgres project at the University of California at Berkeley. As a relational database, Postgres has been in active development for more than 30 years now. It has earned a strong reputation for its proven architecture, reliability, robust feature set, extensibility, and the dedication of the open source community behind the software to consistently deliver performant and innovative solutions. It runs on all major operating systems and has powerful add-ons or extensions, as the community likes to call it, such as the popular PostGIS geospatial database extender. Postgres is also very popular amongst enterprises, so much so that it won the Database Engines DBMS of the Year award 2 years in a row in 2017 and 2018, and is now the first relational database system to win this title again in 2020. So now what we'll do is start looking at running Postgres as a managed service in AWS, and we do offer our customers a couple of options to do that. For customers running legacy data infrastructure on premises, provisioning, operating, scaling, and managing databases is a very tedious and time-consuming and expensive task. You typically have to worry about things like hardware and software installation, configuration, patching, and backups. Not only that, you also have to think about whether your system is performant enough or is resilient enough to be highly available. Moreover, you have to worry about capacity planning. You have to worry about scaling clusters for compute and storage so you don't run out of hardware for data processing. You have to worry about security and compliance and much, much more. From what we've learned on the field, customers today want to spend more time innovating and building new applications rather than spend their time managing infrastructure. With AWS services, you don't actually need to worry about all of that. You don't worry about administrative tasks such as server provisioning, patching, setup configuration, backups, or recovery. AWS continuously monitors your clusters to keep your workloads up and running with self-healing storage and automated scaling so that you can focus on higher value application development. Tasks such as schema design and query construction and optimization are the ones that you should be worried about rather than managing infrastructure. You never have to over or under provision infrastructure to accommodate application growth, intermittent spikes, and performance requirements, and incur fixed capital costs, which include software licensing and support, hardware refresh, and resources to maintain hardware. AWS does this all for you, so you can spend time innovating and building new applications and not managing infrastructure. So the first service that we offer you as a customer to run your Postgres workloads on AWS is called Amazon Relational Database Service. The Amazon Relational Database Service, or RDS, was built by AWS as a way to help customers reduce the complexity in supporting critical transactional applications by making it easy to set up, operate, and scale a relational database in the cloud. RDS automates time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups, while providing cost-efficient and resizable capacity. In essence, it frees you to focus on your application so you can give them the fast performance, high availability, security, and compatibility they need. RDS is available on several database instance types, which are optimized for memory, performance, or I/O, and we provide you with 6 familiar database engines to choose from. So starting from your left, we have Amazon Aurora, which is compatible with MySQL and Postgres. We have the RDS MySQL, we have RDS Postgres, we have RDS MariaDB, SQL Server, and Oracle, which are our commercial offerings. Today, RDS Postgres supports up to Postgres major version 13, which is what we'll be speaking on in this tech talk. The other service we offer customers to choose your Postgres workloads on is our cloud native database called Amazon Aurora. Now, Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. Amazon Aurora is fully managed by Amazon RDS, which automates time consuming administrative tasks like hardware provisioning, database setup, patching, and backups. Amazon Aurora features a distributed, fault tolerant, self healing storage system that auto scales up to 128 terabytes per database instance. It can also deliver very high performance and availability with up to 15 low latency read replicas, point in time recovery, continuous backup to Amazon S3, and replication across 3 availability zones. Today, Amazon Aurora supports up to Postgres major version 12. However, AWS is constantly innovating to add support for the latest versions of our services, and we will start supporting Postgres 13 on Aurora very soon. So, as a customer, you might ask the question, why should I upgrade? Well, as a best practice, always upgrade to the latest minor version. Here at AWS, we often help customers who could have avoided experiencing a production outage simply by upgrading every minor version or two. The Postgres community releases minor version releases very conservatively and for good reasons. A good practice is to keep up to date on those patches. For major release version upgrades, keeping up is not that important, but still a good practice. It's often best to stay on the latest minor release of your current major version and skip a major Postgres release or two before upgrading. You should definitely upgrade if the new major releases will solve your problems which you might be facing currently, such as your current Postgres version is approaching the community end of life date, or if you're planning system changes like operating system upgrades or server migrations or modernizations. If you don't upgrade, you'll miss out on quite a lot of performance improvements in the community, data integrity protection enhancements, and improvements in monitoring and diagnostics offered by new major versions. But do know that any change has a risk, and a well planned upgrade requires thorough testing and preparation. Note that it's usually more time consuming and complex to upgrade from a very old flavor of Postgres to the latest version, and it may need more planning. So it's wise to start planning well before the end of life date. That way, you maintain continuous coverage for security updates and any serious bugs that may be discovered. You should, of course, also allow time to plan and test your upgrades. So, why should you upgrade to Postgres 13? Well, every year for the past few years, the community has been releasing a new major version with new features, along with minor releases throughout the year. Active discussions and ongoing activity are a constant in the community, which continually fuel further development to widen use of Postgres in larger, more critical systems. The Postgres Global Development Group announced the release of Postgres 13 on September 24th in 2020. In every release for Postgres, several people from different companies contribute to different versions of the code base in different stages, ensuring a high level of innovation and quality. This is generally the way the community works. Each year, quite a few new faces join in, which enhances innovation even further. And generally speaking, the Postgres community does not define or have a specific roadmap. Postgres 13 in particular includes significant improvements to its existing indexing and lookup systems that benefit large databases. It includes space savings and performance gains for indexes, faster response times for queries that use aggregates or partitions, better query planning when using enhanced statistics, and much, much more. Along with some highly requested features in the community like parallelized vacuuming for indexes and incremental sorting, Postgres 13 provides a better data management experience for workloads both big and small, with optimizations for daily administration as well as more conveniences for application developers as well as security enhancements. Postgres is an innovative data management system known for its reliability and robustness. It also benefits from over 30 years of open source development from a global developer community and has become the preferred open source relational database for organizations of all sizes. Now let's jump into today's webinar. We are going to look at 4 key themes that come with this release. These themes are primarily centered around continued performance gains, administration optimizations, application development convenience, and security enhancements. So let's start with the first theme around continued performance gains. Now, Postgres 13 performance improvements include both built-in optimizations and heuristics that will make your databases run better out of the box, as well as additional features to give you more flexibility in optimizing your schema and your queries. There are partitioning enhancements, B-tree deduplication, incremental sorts, hash aggregation enhancements, and extended statistics, just to name a few. Let's go over some of these. So, logical replication for partition tables. Partitioning allows you to create a more responsive database by segmenting large data sets using range, list, or hash keys, as many of you might know. Partitioning splits a table into multiple tables and done in a way that is transparent to client applications, making it really quick and fast to access the needed data. On the other side is another major feature for Postgres, which is called logical replication, which gives you the option to selectively replicate which data to copy to a standby. Now, prior to Postgres 13, you could use partitioning and logical replication in Postgres independently, but not together. Now, with Postgres 13, you can use both of these features together. As an example, previously partitions had to be replicated individually in Postgres 12 and below. Whereas in Postgres 13, a partition table can now be published to a subscriber explicitly, causing all of its partitions to be published automatically. Addition, removal of a partition causes it to be added to or removed from the publication. There is a new published via partition root option in the create publication command, which is shown here, with which you can now control whether changes to partitions are published as their own or their parents. Another change that was previously there, which allowed subscribers to not receive rows into not partition tables, has been introduced. Now with PG13, you can receive rows into partition tables on the subscriber side. The benefit of this, of course, is that it gives you a tremendous amount of flexibility. You can now do all sorts of permutations and combinations with logical replication and partitions, meaning that you can now replicate from a partition table to a non-partition table on the subscriber side. You can replicate from a non-partition table to a partition table, and of course, from a partition table to another partition table on the subscriber side. Logical replication is no longer constrained because of partitioning. Of course, we don't stop there. There are more partitioning enhancements in Postgres 13. Previously, Postgres allowed you to efficiently join partition tables only if they had matching partition boundaries. In Postgres 13, partition-wise joins allow you to efficiently join tables even when their partition bounds do not match exactly. The benefit is that joining partition tables is much faster, which encourages the use of partitioning and therefore a more responsive database. Row level before triggers are also supported on partition tables with Postgres 13. Postgres 13 introduces a way for B-tree indexes to avoid storing duplicate entries in some situations. In general, a B-tree index consists of a tree of indexed values, with each leaf pointing to a particular row version. Because each leaf points to one row version, if you are indexing non-unique values, those values need to be repeated. The deduplication mechanism introduced in Postgres 13 now avoids that by having a leaf node point to several row versions if possible, which leads to smaller indexes. To demonstrate this, I have a pretty simple example. I have Cloud9, which is a terminal window which we use to query the Postgres databases using something like pSQL. And here in my example, I'll be showing you two different databases, so Postgres 12 on the left and Postgres 13 to the right. So here what I'm doing is just checking the versions, making sure the versions are 12 and 13. Now what I'll do is start off by creating a table T1 on the left in Postgres 12 with two columns of type integer and text. And I'm going to insert about 1 million rows with the same set of characters in column B. I'll do the same thing on Postgres 13. So literally replicate the same thing on the Postgres 13 instance. And now also what I'm doing is checking the size. So I use a function called pgcrypto, which basically rounds it up. And you'll see the same sized index is 39 MB in Postgres 12, whereas due to the deduplication feature introduced in Postgres 13, it's now actually 5 times smaller in Postgres 13, with the size of the same index being around 7 MB. What's the benefit? Well, smaller indexes are faster to load from disk and take up less space in memory, meaning there's more room for your data. So this is huge. The other benefit is incremental sorts. Sorting data is a common database task, and Postgres has a number of features to avoid unnecessary work here. For example, if you have a B-tree index on a column and you query your table ordered by that column, it can just scan that index in order to get sorted data. In Postgres 13, this is improved to handle partially sorted data. So let's say if you have an index on a column A, or the data is already sorted by column A, and you issue a query to order by column A, comma B, Postgres will understand that the input data is already partially sorted and can avoid resorting the whole data set. This is especially useful if you have a limit in your query, since this can avoid even more work. Now, note that here I'm inserting about 10 million rows. As you'll notice, to see the incremental sort benefit, you need to have a relatively large working set. So I chose 10 million rows in this example, where we'll start noticing the benefits as shown by the query plan later on. So I insert about 10 million rows on the left in Postgres 12. I do the same on the right in Postgres 13. I create an index on a column A in both the sides, and then I'm running vacuum freeze. So we'll wait for the operation to complete on the right side. Once it's done, I'll run an explain on the query ordered by A. You'll see a pretty basic index scan, which is generated by the optimizer. This is similar on Postgres 13, no changes here. But the moment you start introducing a new column, let's say now I do an explain with order by A, comma B, you will actually see the difference here. Notice one, that rather than a sort in Postgres 12, you now have an incremental sort operation in Postgres 13. And secondly, the cost is much, much lesser, meaning that you have a very quick running incremental sort rather than resorting the data all over again. This is huge as well. The next feature that is introduced with Postgres 13 is called disk-based hash aggregation. Now, disk-based aggregation allows you to use your disk storage for larger aggregation result sets. Previously, in Postgres 12, hash aggregation was avoided if it was expected to use more than what was specified in your worker memory. Now, work mem is a parameter that specifies the amount of memory to be used by internal sort operations and hash tables before writing to temporary disk files. In Postgres 13, a hash aggregation plan can be chosen despite that. So basically here, the hash table will be spilled to disk if it exceeds your memory allocated in work mem. And anytime you have work mem times hash mem multiplier, which is the new parameter which is introduced, which is used to compute the maximum amount of memory that hash-based operations can use, it will start using that new operation called hash aggregated, which is highlighted here. The benefit obviously here is that you have more memory for your working set available in work mem, which any subsequent queries coming in can make use of. Postgres 10 introduced the concept of extended statistics. You may ask, why are statistics important? Well, Postgres keeps some stats about the shape of your data to ensure it can plan queries efficiently. But the stats kept by default cannot track things like intercolumn dependencies. Extended statistics were introduced to address that. These are basically database objects. You can think of them like indexes that you create manually with the create statistics command to give the query planner more information for specific situations. These would be expensive for Postgres to determine automatically, but armed with an understanding of the semantics of your schema, you can provide that additional information. Used carefully, this can lead to massive performance improvements. Postgres 13 actually brings a number of small but important improvements to extended statistics, including support for using them with an OR clause and in or any constant lists, allowing consideration of multiple extended stats in planning a query, and support for setting a statistics target for extended statistics. The next theme that we'll talk about is around administrative optimizations. So broadly in Postgres 13, there have been a lot of administration optimizations, out of which I will list a few of these here, and we'll cover these very briefly. The first of them being parallelized vacuum for indexes. Now, Postgres multi-version concurrency control means that you need to run vacuum regularly. The main purpose of vacuum is to clean up old versions of updated and delete rows, but it is also essential to set pages as all visible for MVCC bookkeeping. All visible pages allow index-only scans to avoid checking visibility status row by row, making them really, really fast. In Postgres 13, one notable improvement is that multiple indexes for a single table can now be vacuumed in parallel. This can lead to big performance improvements in vacuum work, which was not possible earlier. Now with Postgres 13, parallel vacuum is the default and can be controlled with the parallel option, as you see on your screen, where you basically specify parallel as an option in parentheses. Then 2 is the max parallel maintenance workers, which you specify as your configuration parameter. So for parallel vacuum to occur, there are certain conditions which need to be true. First, sufficient parallel workers should be available. Now, this is the parameter that we just talked about, which is the max parallel maintenance workers, which by default is set to 2. You can, of course, increase it. Second, there should be multiple indexes on the table, since only one index can be processed by one worker at a time. And third, the indexes should be large enough to exceed a threshold. And the way we define this threshold is by the configuration parameter called min parallel index scan size, which defaults to 512 KB by default. Note that parallel vacuum is currently not supported for autovacuum. This new feature is intended just for use in manual vacuum runs that need to complete quickly, such as when insufficient autovacuum tuning has led to an imminent transaction ID wraparound, and you as a DBA need to intervene to fix it. The next feature is inserts now trigger autovacuum. So previously with Postgres 12 and below, insert only activity would trigger auto analyze but not auto vacuum on the grounds that there could not be any dead tuples to remove. However, a vacuum scan has other useful side effects such as setting page all visible bits, which improves the efficiency of index only scans. Also, allowing an insert only table to receive periodic vacuuming helps you to spread out the work of freezing old tuples so that there isn't a sudden amount of freezing work to do when the entire table reaches the anti-wraparound threshold all at once. Now in Postgres 13, the auto vacuum background process can be triggered by insert statements. And this new behavior can be controlled by two new parameters called auto vacuum vacuum insert threshold and auto vacuum vacuum insert scale factor. The write-ahead log or wall in Postgres ensures your data stays consistent in the event of a crash, even during mid-write. Consistency is a fundamental property of any database, and it is very true of Postgres as well. So it ensures your transactions either commit or did not commit, so you don't have to worry about in-between states. On a busy system, wall writes, these transaction log writes, can often be a bottleneck. To help diagnose this, Postgres 13 now introduces more information on your transaction log or wall usage from your queries. When you run an explain now with any query that you want to test with the option wall, you can now actually generate information about wall records that will be generated by that query. This includes things like the number of records and the amount of wall generated in bytes, shown here with the example. We looked at logical replication previously. So logical replication does include a concept called replication slot. And a replication slot in logical replication is used for something called logical decoding in Postgres. The whole idea behind logical decoding is to give users a chance to attach to the transaction or the write-ahead log, as we call it in Postgres, and decode it with a plugin. It allows you to extract changes made to the database and therefore to the transaction log in any format and for any purpose. With Postgres 13, you can now specify the maximum size of transaction log that replication slots are allowed to retain on the primary instance through a new parameter called max slot wall keep size. If the max slot wall keep size is -1, which is the default, replication slots may retain an unlimited amount of wall files. You can monitor the wall availability of replication slots in the system view called pg replication slots wall status, where possible values are reserved, extended, unreserved, and lost. Reserved means the wall files are within your max wall size configuration parameter. Extended means that max wall size is exceeded, but the wall files are still retained either by the replication slot or wall keep size parameter. Unreserved means that the slot no longer retains the required wall files, and some of them are to be removed at the next checkpoint. Whereas lost basically means that some required wall files have been removed, and this slot is no longer usable. The analyze command in Postgres collects statistics about specific table columns, entire tables, or entire databases. The Postgres Query Planner then uses that data to generate efficient execution plans for queries. Postgres 13 has added a new system view called pgstat progress analyze that you can now use to report the analyze progress. So this is a very neat addition in terms of monitoring capabilities in Postgres 13. Drop database was previously supported, and it has been supported from very early versions of Postgres. But until now, drop database was not allowed if any of the sessions connected to the database being dropped was active. In Postgres 12, for example, if you try to drop a database when there are active connections, you'll get an error, which is shown here. Whereas in Postgres 13, a new option is added to the drop database command. This is called force and use it like such. So drop database test with force. Drop database using the force option will terminate all your existing connections to the database and drop the database. So this is very, very powerful. Use it with caution. The next theme we'll talk about is around application development convenience. These are small improvements that the community has made to the Postgres database itself in Postgres 13. This will help developer productivity as we look at these briefly in the next few slides. Sometimes customers typically ask me about the best choice for auto-generated primary keys in Postgres. You can do it through two ways in the Postgres database. One is generating keys with a sequence, or you can use something called a UUID. Now, a UUID, or a universally unique identifier, is a 128-bit number that is generated with an algorithm that effectively guarantees uniqueness. In Postgres, there are a number of functions that actually help you generate these UUIDs. And those who are familiar with Postgres, the UUID OSSP extension is the most common extension used to generate UUIDs. The UUID OSSP extension ships with Postgres, but it has to be enabled explicitly to create UUID generation functions. Postgres 13 now ships with a new function called gen random UUID function, which is available by default. And if you were only using UUID OSSP for that function, you'd no longer need the extension. So you'll see on the example here that I have no extensions installed on my database. And without the OSSP extension, I can literally just do a select gen random UUID function, and it will help me generate a random UUID for my application. Another neat addition in Postgres for developer productivity is a datetime method that converts a character string to a datetime type. This function allows JSON values to be converted to timestamps, which can then be processed in JSON path expressions. The LCM function, which returns the least common multiple, and the GCD function, which returns the greatest common divisor, both of these have been added. You can now specify two numbers of the same type in the parameters, and Postgres will actually generate the GCD and LCM for those. If you have 0 for these parameters, of course, you'll get 0. So these are also very valuable functions if your application requires calculating GCDs or LCMs. The final neat addition has been to the pgbench tool. So the pgbench tool in Postgres is used for performance testing or benchmarking data. And it can give you pretty good data around TPS and latency, along with other relevant performance statistics. So Postgres 13 now allows pgbench to partition its accounts table, making performance testing of partition tables much, much easier. It currently supports two partitioning styles, so hash partitioning, which is shown here, as well as range partitioning, which is shown here. List partitioning is currently not supported. Finally, let's look at some security enhancements in Postgres 13. So there have been quite a bunch of these actually, and I've included just the highlights here. The first one being the minimum TLS version now supported on Postgres 13 is 1.2, which has been upgraded. So Postgres 12 introduced two new server settings. These are the SSL min protocol version and the max protocol versions. As the names indicate, these are used to control the minimum and the maximum version of the SSL and TLS protocol family that the server will accept. The reason new versions of TLS are developed, amongst other reasons, is that security issues are found in the older versions. So almost universally, using a later version is almost always better than using a previous version. With Postgres 13, the default is TLS 1.2, which satisfies industry best practices and is considered very secure. As you might know, Postgres has the power of extensions to add feathers to its cap without disturbing much of its core. In other words, extensions in Postgres enhance functional capabilities of a database in a non-intrusive way. In fact, there are many third-party organizations who have used the extensions mechanism to generate amazing feature sets. PostGIS, pglogical, pgcron are some of these great examples. Previously, if you are a user, note not a super user, and you try to create an extension, you would get the error that your permissions are denied to create the extension. And you'll get a hint that you must be a super user to create this extension. Postgres 13 now introduces this concept of a trusted extension, which allows for a super user to specify extensions that a general user can install in their database as long as they have a create privilege. So here, as an example, a user demo with create privileges on database pglab is able to create certain extensions. Note that not all extensions, but certain extensions, such as hstore, Itree, pgcrypto, plperl, etc. You don't get that error anymore. The next security enhancement is avoiding man-in-the-middle attacks for passwords. How do we do it? So we do it through SCRAM channel binding. libpq is the default set of library functions that client applications use to query the database in Postgres. It's important for these connections to be secure. Otherwise, there could be an opportunity to impersonate the server, also called a man-in-the-middle attack. Many different security protocols can be used to encode the password, which is typically sent by the client. And a good example is SCRAM SHA-256. So this new enhancement in Postgres 13 now enables SCRAM to use channel binding, which is a feature that allows mutual authentication over an SSL connection when you're not using certificates. SCRAM with channel binding is a variation of password authentication that is very easy to use and also much more secure. This option controls the client's use of channel binding. A setting of require here means that the connection must employ channel binding. A setting of prefer means that the client will choose channel binding if available. And a setting of disable prevents the use of channel binding altogether. The default in Postgres 13 is prefer if Postgres is compiled with SSL support. Otherwise, the default is disable. The final enhancement in the security space that I want to talk about today is the Postgres foreign data wrapper and how certificate authentication is supported now with Postgres FDW. So the Postgres foreign data wrapper or Postgres FDW is used to connect to remote Postgres databases. This basically gives you the ability to query multiple databases from your existing Postgres database, leveraging things like querying remote data sets so that you can join multiple and disparate data sets to get more powerful results. With Postgres 13, now your Postgres database certificates support certificate authentication with Postgres FDW. And what this basically means is with Postgres 13, non-super users can now connect to Postgres foreign servers without using a password. All you need to do is set password required flag to false for a user mapping and specify the SSL key and SSL cert in connection options, and you're good to go. All right, let's jump into a quick demo on how to upgrade your Postgres 12 instance to Postgres 13 using the console. Note that I'm using a very simple setup. I have a Postgres 12 instance that I'll use, and I'll use that to upgrade to Postgres 13 using RDS. There are no custom parameter groups, and the purposes of this demo, I'm assuming no major activity on the database. In the real world, it'll obviously be different. So do have an upgrade strategy in place. We have great documentation for a step-by-step upgrade process. So I'd encourage you to read through the documentation thoroughly before performing an upgrade. So here on the RDS console, I'm working with a Postgres 12 instance. Step one here is to select the database instance and click Modify. Here, what I'll do is select the major version in the dropdown for the DB engine version. I'm going to select 13. In parallel, what I'm also going to do is initiate a script to check the current time and version, which is my Postgres version, every 5 seconds. This also helps me to see my connectivity to the database from an application standpoint during the upgrade. Now that the script is running, I'll go back to my console, verify all configuration parameters. We're not changing anything here. So once verified, click continue. And do note that once you perform a major version upgrade, you cannot downgrade. So pay careful attention to that. And since I'm not doing this in a production setup, I'll just select apply immediately and click modify. At this point, I'll refresh my console view to see that the status of my instance changes from available to upgrading. And this takes a few minutes. And to test that, what I've done is I'll go back to my script, which is running. And I'll notice a little bit of a downtime here. So you'll notice that the connection abruptly terminates. Note that here I'm highlighting the time it was up, and now the time it took to come back up. So there is about 11 or so minutes of downtime here. And if you go back to the console, you'll see that the status changes from modifying to available in a matter of minutes. Also note that in the status of modifying, I was still able to connect to the database, which is where I was able to run my query and see the timestamp. In addition to the things we saw today, Postgres 13 has added a large number of features and improvements to the existing code base. For a complete list of new features, you can refer to the official release notes on the Postgres website. Of course, this is a very short rendition of what we think is worthy of highlighting today. However, Postgres 13 has over 170 enhancements. There is something for everyone. There are more improvements to the optimizer, for example, improving the optimizer's selectivity estimation for containment and match operators. There are performance improvements for truncation of very large tables. When you're using lock table on a partitioned table, we do not check permissions on the child tables anymore. And there are a number of pSQL, which is the client used to query Postgres databases, enhancements as well. So show table persistent in pSQL's meta command called dt+, and much, much more. I would highly encourage you to read the release notes, which is linked here, for a comprehensive list of what's new in Postgres 13. With that, we come to the end of our webinar today. Thank you again for taking the time to learn about the new features and enhancements in Postgres 13. Hope this was useful and wish you all a great rest of your day.